Hello there, friends and fellow Modonauts. I spent the last 10 days or so working on the material system and workflow I'm going to use for most of all the assets in the game. So this is what I want to show you today in this update. The material system and workflow is an integral part of the whole project, so I wanted to get this done as soon as possible. I used a small prop as a test bed for the material system. As you can see here, the armor segment, a crafting piece in the game, with the full material assigned. And I want to show you the whole process that went into creating this piece. Starting in Modo, I explain what needs to be done to work with the material system. Then in Substance Painter, I will show you the whole process of mask creation and export. And then finally in Unreal, show you the materials and layering system that put everything together. So this piece you can see here, it has no baked textures like color maps or normal maps and all that stuff. This material here you can see is a kind of layering system where you have bare metal underneath, then you have painted metal on top, different masks that create the edgeware, that create the dirt on top of it, and so on. So this is how this material system works, with tileable materials that can tile infinitely so that we have real high detailed textures and we don't have to worry about low texture resolution and all that stuff. Once we get to the Unreal part, I will show you more what went into doing this. So let's head over to Modo first and show what I had to do to create this. So here in Modo you can see the piece and it has rounded edges, and like I shown in the other videos, I used transfer normals to get rid of the shading errors and all that stuff, and using simple Atlas UV projection, I created this whole piece. And then I had to create another UV map, which is very important because it defines the system for a consistent texel density over all the objects. So you can see here under UV 0, it's the 0 to 1 UV space. This is for the masks and stuff that will be created. And the other UV map is for texel density. So I used or copied the whole UVs here and then in UV1, and then I used the texel density tool to define 1 meter is 1024 pixels and applied it overall. And this is what I'm going to do for all the other objects, so that in the end they all have the same texel density. And this is important later in the Unreal material that I will show you, where I'm using this UV map for texturing or for placing the material layers. So this is one important step, the UVs. The next thing, it might be optional, but I'm using this as a kind of ID map. I'm using vertex color painting to define the areas of different materials. Like, let's go back to Unreal for a second. You can see here the more purplish color in the back is the base color, and the greenish colors of those front bars, these are painted through vertex colors or defined through vertex colors. So in Modo I created a vertex map, and basically it's a RGB or RGBA map, and then used set value on that to define specific polygons with a color. And so if you look at the vertex map, you can see here the base is red and these front bars have green vertex colors. And in Unreal I can access these or use a specific layer blend item that I will show how this works later on to pick that color and then assign a different material to this. So these are the two important steps in Modo, using vertex color as an ID map and using the specific UVs or the two UV maps for texel density and for the masks. So let's head over to Substance Painter. And you can see here the item in Substance Painter, and I created specific fill layers for those different masks like edgeware, dirt, rust, which I'm not using here in this case, and roughness variation. For that I used or created several custom channels. So we have a base color channel, which is just a normal color, and then user 0 to user 4 different custom channels for edgeware, for rust, for roughness variation, dirt, and I'm using A for another one that might pop up in the future that I might be able to use. And the way that works, if I go to layers and select maybe edgeware, we can see here that for each of these layers we have the materials that you can enable and disable, which writes basically the values into this black masks. So each of these layers has a black mask, and in these masks you several different possibilities using generators for edgeware and other painting and to create these black and white masks. And this base color basically is important so that we can see what those masks look like. For example, if I select edgeware and I can enable color and it's black and white, so you can see here on this mesh the edgeware that is happening. The same thing if I turn that off and go to dirt, for example, and turn on color, you can see the dirt mask in effect on this mesh, or the roughness variation that I'm going to use as well. And on the base layer, I enable everything and set the values to black for dirt, roughness, and so on for all these custom channels. And each other layer only has this enabled, which we want to export. For edgeware, it only has the edge channel enabled, dirt has the dirt enabled, and so on. And this is important when we go into exporting all this. So let me show you the output template for that. I have the UE5 masking workflow, and I'm creating 2 textures. So usually what you would normally do is save every mask as its own texture, but that would be a lot of textures, so we need to save texture space. And this is why I'm only using 2 different textures and using channel packing to pack every single mask into its own texture. So here under one texture, the masks, I'm saving channel 0, this is edgeware, then channel 1 is dirt, and B and A. B is rust, and A is not used. It might be the A channel that I created, but this is not defined yet. And then the other one saves the roughness variation into the R channel, and ambient occlusion, so that's the map that I baked in Substance Painter that is put into the G channel of this texture. And then I basically create a 4K texture and export these as Targa files, and then I have my 2 textures. So let's head over to Unreal and I will show you how this all fits together. So in Unreal, we can see here that we have our armor segment. These are the 2 masks. They look a little bit weird. If we open it up, for example, you can see without the alpha channel, this is the combined map. And if we look at every single channel, you can see here, this is the edgeware. This is the dirt, I think. And B is not used, which was rust. And the same with the other map, where we have the roughness variation in one and the AO map in the other channel. So these are the textures or the masks that we will be using. And to showcase the material system, like I said, each material is based off layers, material layers. So I created some simple materials like metal H scratched and painted metal and a different painted metal version. And these layers, if we look at them, they have 2 different textures. Oh, maybe I forgot one other step, but this is optional on how to create it. Let's have a look at Substance Designer. This is a Substance Designer where I created, let's say, that painted metal, the basic painted metal. Simple graph, basically, for using the normals with crunches and dirts and stuff. We have the metal, and the important thing is here as well, every material layer, if you're used to in Unreal, you usually have your color map, you have your normal map, and then like an ORM map for ambient occlusion, roughness, and metalness. And I'm going to save more texture space again by combining severals and not using, for example, the metal map. And this is what I'm doing here in a kind of masking export file where I have my painted metal and I create a base color and a normal, but I'm using the alpha channel of each of these files for different outputs. So I put the roughness map into the alpha channel of the color map and the normal map, if that texture, which isn't the case here, but other may have an ambient occlusion map, which I will put into the alpha of the normal map. So I kind of like create only 2 maps instead of 4 for each material layer. And you can see these here where I'm using the base color and the normal, and inside that material layer, which I will show you in a second, I'm reading different channels and creating that material layer. So let's have a look at how this works. I have master materials, which is the layer plant material. This is the main material from which you will create instances for each mesh. For example, the MI armor segment material instance for the armor segment, it's an instance of that material layer plant material, and I can set several things. But you're wondering, where does all the magic happen with the masks and stuff? So here in details, I define the basic default values that you can see here, like if there's a baked normal map, we can define baked normal, the roughness amount for the roughness variation. I'm using the roughness variation overall over the whole mesh. So, and the ambient occlusion input. So this happens in the general section, and this material also has, if we go into the material instance, a layer parameters, and this is where the magic happens. Let's close these single layers to show more what's happening and show you this different layers before I go into how these layers work. So we have a background layer, which is the painted metal, which has a color tint of this purplish pinkish metal. And then we have another layer where I'm using the same painted metal, but only with a greenish tint, which will be the front bars. And in this case, we have a blend asset. And there are several blending assets. In this case, it's a vertex color, which comes with Unreal. And I created my own layer blend for using the masks, which I will show you soon in the Edgeware. So you can see here, I'm using this blend method and choose the green channel. The green channel is basically the vertex colors that define the front bars here. And if I would use the red channel, then you can see it switches around. It's green in the front and back. So you can use these vertex colors to define different materials on the same mesh without having to use an ID map or something. And then on the Edgeware channel, you can see here the basic mask plant. This is the layer or the plant asset that I created. And I can define the map. So in here, it's our mask map. And then under parameters, I can choose the channel, which channel to use. And in this case, it's red, so it's the Edgeware, and it basically uses a metal, that's a bare metal age scratched, which will then show up where the Edgeware is defined. Like you can see here, that's the bare metal shining through. And this is how the whole system works. You can define several layers, add more layers. And what I did here with the dirt, I used the painted metal again with a dark brownish color or light brownish color. And instead of using the red channel, I'm using the green channel, which is dirt. And so it's putting the dirt where I defined the dirt in Painter. And this is basically how the whole system works. We have layers, and it's like Photoshop basically. You can create more layers and blend them together with these different masks or these blending assets, which can be a basic mask blend, vertex colors, and some more come from which I haven't looked into yet, that are included in Unreal. Like the vertex color came from Unreal, and I'm using the basic mask blend that I created, which is a really simple item. So let's have a look at these. For example, this is the basic mask blend function, which has a mask texture as input, and using this mask parameter node, which can then change between these different 4 channels. And I'm blending the top and the top and the bottom layer together, and this is all that's needed for the blend, and this is how it's for the blend item, and that's how it works. And if we look at, okay, how does the material layer system work, or how does a layer work? And for that we need to create, or in Unreal create a material layer item, and this is where all the magic happens for these layers. And you can see here I'm using UV, or the UVs from channel, or the UV map 1, and that's the one for the textile density. UV 0 is used for the masks, so this is where this comes in play. And then I have a base color. In my color texture I have the roughness in the alpha, like I'm shown in Substance Designer, and the normals, I have the AO in the alpha channel of the normal map. And I'm just using different things if I have a color map, or just use simple colors for simple metal material or stuff that I can create. So this is not done yet, so this is first implementation of it. We have the roughness, ambient occlusion, metalness. Metalness is just for now a simple value, and then I'm creating material attributes and set them in that layer, and this is how it basically works. So if I look at an instance of this material layer, then I can define the textures, I can define the tiling. So basically if I tile 3 times, 2 times, but overall, when this is applied to a mesh which uses the second UV channel, then textile density is overall the same. And then I can use color tints and stuff. So this is how layers work. We have the material layer and a material that uses blending that defines the basic material for that, where we can then use in that material the layer systems and add these layers. This is how the system works, and it's really powerful. We don't need to bake textures to a certain resolution and eventually have problems because a 2K or 1K texture might not look as good as tileable materials, which has infinite details. So this is how this thing works. And I'm going to use all this for all the other meshes like the walls and the map and so on. And the only thing where I'm probably not using this is when it comes to more environmental pieces like rocks and some other stuff, where I might use a triplanar material with vertex painting and so on, but this comes in the future. For now, this is an interior map with painted metals and all that stuff, so this is where this material will come in handy. So this was a small detour, but now I have this material system working, at least in the beginning stages. And the next steps will be, again, continuing the map and creating all these pieces and so on. And for those, I want to show you as a one last thing, where I will probably use plasticity more now for modeling, because in the newest beta, there is a feature that really helps me out putting my base meshes from the original versions into plasticity, where I can then start modeling on them. Let me show you this as a real last thing. So here's the newest beta, and let me import, for example, the armor segment base as a test. And usually when you import it OBJs or FBXs or whatever into plasticity. They were more like a reference, but you couldn't do much with them. Let me rotate this real quick, 90 degrees. And the cool thing about this beta now is that if I import this, I can use it as a reference where it anchors the points on the edges. So I can really go in and draw the lines, draw the lines and create the basic shape in plasticity. And then can extrude it out and start really fast modeling based on my original meshes. And the Boolean system, everything here is much more powerful than I think in Modo, or it's easier and faster. And I'm looking for the fastest way possible to creating these meshes. So this new feature in plasticity is really a godsend for me now. I saw it by accident that this was there, and I have the studio version so I can use the beta, and I think the final version will come out in September or something, or the newest version which has all these features. But this is really great now. I can add my simple meshes, append them here, and then create the simple shapes by snapping on these vertices and stuff. And so this is really helpful. This is what I wanted to show you, what I will be using in the future. So I guess this is it for this video, small update on the material system, and I hope I see you in the next video. Take care. Bye bye.